Before beginning our exploration of how do you find outliers, the first thing that I need to make a notation of is that the numbers do have to be in order. And the reason why, we're going to be finding the quartiles Q1, Q2, Q3, and also the IQR, which requires the numbers to be in order. So as you can see, these numbers here are not in order. In this video, we're going to look to see how we calculate outliers in a data set. But before we do that, we'll talk about these three number sets here and look at what some differences are between the number sets. So in the first one, we notice that the numbers are kind of evenly spaced out and no one number stands out. In the second one, the first five members of the data set are pretty closely spaced, but then all of a sudden we have this one number that is very different from the others. And then in the last one, the numbers have a spread of 0. There's no difference between all of these threes, but over here we have a single 2. So what would make one number an outlier? This one is going to be an outlier. We'll do a number set like it. And this number, it's not very different. Like over here, we had a 2 and a 3. It's over here, it's not very different from the others, but the others have a bigger spread between them. And these have a spread of 0 between them. So the 2, in this case, is the only unusual member of the set. So I strongly recommend that you watch all three of the examples in this video because each one is going to cover a special case and you might need to know those for school. To find low and high outliers, we'll start off by writing the formula for both. So the low outliers are numbers that are less than Q1 minus 1.5 times the IQR. High outliers are greater than Q3 plus 1.5 times the IQR. Now, in order to do this, I need to know what the quartiles are, and the IQR means interquartile range, so it's the distance between Q1 and Q3. Over here, I'm going to put Q1, Q3, and IQR. Now, looking at our number set, the middle of the first half, which is Q1, is a 4, so I'll write that there. And the middle of the second half of the set, the middle number is an 8, so I put that there. And the interquartile range, the range between Q3 and Q1, is 4. Now I'll just plug those numbers in over here. So I have numbers that are less than this for low outliers, or Q1 is a 4 minus, and 1.5 times the IQR, which is a 4. So what I have is 4 minus 6. So once I subtract, 4 minus 6 is minus 2. This is a version that would be for 7th grade because it has the negative numbers, but it works the same for 6th grade. So the low outliers are numbers smaller than minus 2. And then for high outliers, we'll just substitute. Q3 is an 8 plus, and then 1.5 times 4 is again going to be 6. So I have 8 plus 6 here. So high outliers are numbers that are greater than 14. Now, looking at my results, let's take a closer look at why there's a Q1 and a Q3 in the formulas. Well, the low outliers are going to be, this is Q1 here, so low outliers are going to be to the left of Q1 on a number line, and high outliers are going to be to the right of Q3 on a number line. So it'd be Q3 plus and then Q1 minus. So looking at this, the rest of the formula, the IQR is kind of a measure of a range between the middle of the first half and the second half. It's this range over here is the IQR. The smaller the distance for this IQR, the less change a number has to be in order for it to be an outlier. Now here, it says that the low outliers are less than minus 2, but since I don't have a number smaller than minus 2, there are no low outliers. And since there are no numbers that are greater than 14, That means there are no high outliers. Here our number set has 7 pieces, and when I split it into 2 halves, I'm not going to count the middle one. So the middle of the first half, which is 5, that's our Q1, and the middle of the second half is also a 5, so that's Q3, and the IQR this time is a 0. So here are our 2 formulas again, and we'll just plug the numbers in. So for low outliers, it's numbers smaller than Q1 is 5, minus 1.5 times the IQR, which is 0. And then this whole thing is just going to be 0. So low outliers are numbers less than 5. And then for the high outliers, I need numbers greater than Q3, which is 5, plus, and 1.5 times 0 is still 0. So high outliers would be numbers bigger than 5. So looking at this, it might be surprising because the 4 is not very different from all the other numbers, but since the spread of these numbers is 0, it's very sensitive to a change in one of the members of the data set. So the slightest change, even if this number was 4.9, an outlier. So low outliers are numbers less than 5. We do have a low outlier, and high outliers are numbers greater than 5. And over here, we don't have a number that's bigger than 5. So there are no high outliers. In this example, we have a string of repeated digits followed by an 80, which is a very different number, and it's likely a high outlier, but we still want to test it. First thing we need to do is find Q1, Q3, and the IQR. Let's list the 2 formulas. So now we'll simply substitute our values. So for the low outliers, they're numbers that are less than Q1. Well, Q1, if I look here, is a 2. I'll put that there. Over here, Q3 is also a 2. That makes my IQR 0. So now we'll substitute. So Q1 is 2 minus 1.5 times the IQR, which is 0. So 2 minus 0 is just 2. So low outliers are numbers smaller than 2. Well, over here I can see I don't have a number that's less than 2. So there are no low outliers. Now for high outliers, let's substitute. I have numbers greater than Q3, which is 2, plus 1.5 times the IQR, which is 0. So this is just going to be 0. So high outliers are numbers greater than 2. Well, I do have one. So 80 is a high outlier equals 80. So this 2 here isn't a member of the set. High outliers are greater than 2. It's just telling you this is the threshold where a number would become an outlier. And 80 is an outlier.